In this video, I'm going to show you how to use Python to fit a logistic regression model for the sludge data. First, we import the libraries that are needed: pandas has PD, statsmodels.api has sm, and math. We are going to read the CSV file sludge.data separator equals space. Then we check the data types of the columns. We are going to use the Claydos and fold columns, and the data type for Claydos is int64 and for fold is object. So first we need to change the columns of the data type for column Claydos to categorical. So this is how we do that. So first check the levels of the Claydos column, and then create and assign the categorical object to the column Claydos. So pd.categorical in bracket we will have df of the name of the column, then comma categories equal levels, comma order equal false, then print the data type. For this we have the data type for column Claydos changed to category. Then we will do the same for the fold column. So levels of the column, and then we will create and assign categorical object to the column fold. So this is how we do that. So df square bracket fold equal pd dot categorical bracket df fold, comma categories equal levels, comma ordered equal false, print the data types. Fold column, the data type is changed to category. Then we get dummies for columns Claydos and fold. As we can see, if I just do df, if I just print the data file, so before the Claydos column was one column, and after, so it's one column. So 3, 2, and 1 are the levels of Claydos column. So we want to create dummies. Dummies, what it will do, it will create 3 level columns, which is Claydos 3, Claydos underscore 2, Claydos 1, and it will assign true or false. True if that is that has a value, and false if it doesn't have a value. So this is how we do that. Get dummies for columns Claydos and fold. So first we will do for Claydos over here. So pd dot get dummies bracket df dot columns equal square bracket Claydos. Use so df dummies will look like this. Now we will do the we won't do the dummies for the fold column, but instead there are 2 levels, yes and no. So y for yes and n for no, and we will change y to 1 and n to 0. So this is how we do that. And also for Claydos 3, Claydos 2, and Claydos 1, the dummy columns that we created, we will replace true with 1 and false with 0. So dfw square bracket the column name Claydos underscore 3 dot map bracket curly braces, true is assigned to 1, false is assigned to 0, and same for Claydos 2 and same for Claydos 1. And for fold column we will do df dummies. Dummies because we named the df column after creating the dummies for Claydos column. We changed we created a df underscore dummies, and we will use df underscore dummies. So here df underscore dummies square bracket fold dot map bracket curly braces y for n, and we will replace n to 0. Print df dummies. So we can see that fault column now we have now replaced by 0 and y replaced by 1. Kaleidos 3, we will have 1 for all those having true and 0 for false, and Kaleidos 2 and Kaleidos 1 same. Then we will create a formula. So the binary logistic regression with logit-link function. So this is the function that we will use. Fold equal Kaleidos underscore 3 plus Kaleidos underscore 2 plus Kaleidos underscore 1. So this is how the formula looks like. And we will separate the feature variable x. So df dummies, we will drop SVI column, sludge FD column, and fold column. So all those Kaleidos 3, Kaleidos 2, and Kaleidos 1 are assigned over here. And this is how it looks like. And then we will separate the target variable. The target variable is, as we know, the fold column. So we will drop the rest of the columns, and fold column looks like this. Now we will add a constant term for the intercept. So x equal sm dot add constant, add underscore constant to x, and this is how it looks like. So we can see that 1 is added as a constant. Then we define the logistic regression model using binomial family with logit link. So this is how we do that. Model equal sm.logit of y comma x dot fit and the model. So maximum number of iterations has been exceeded. There is a warning. Current function value 0.347122 iterations 35. So it gave us bit of error over here for maximum likelihood optimization. Print the model summary. So when we print the model summary, the dependent variable is fold, number of observations is 1727, model is logit, method is MLE, maximum likelihood, and log likelihood, p-value. Then we have constant. This is the coefficient of constant, minus 1.2352. Kaleidos 3 has constant 0.9383. Kaleidos 2 has constant minus 0.2464. Kaleidos 1 has constant minus 1.9272. So let's answer some of the questions related to this. The estimated probability of falling when the level of Kaleidos is high, should be level here. Kaleidos is high, so we will do the exponential math.expon exp bracket. So coefficient of Kaleidos 3, which is 0.9383, and we will add it to the constant, which is minus 1.2352. And then we divide that by bracket 1 plus math.exp of the same value. So, and that gives 0.4263 and so on. Then the estimated odds of falling when the level of Kaleidos is high is given by math.exp of 0.9383, which is the coefficient of Kaleidos 3, and added to the coefficient of constant minus 1.2352. That is the intercept. And that gives 0.7431 and so on. Then we'll find the estimated odds ratio that compares the odds of falling when the level of Kaleidos is high to that when it is low. So this is how we do that. Math.exp bracket. So we will take the coefficient for Kaleidos 3, which is 0.9383, and we will subtract the uh, the lowest level, which is Clados 1, and level is 1, and the coefficient of it is minus 1.9272. So we will subtract that, and that gives 17.5578, and so on.